Hello everyone, welcome to IT Security Labs, and thank you very much for joining me tonight. I'm very excited to be here, and I hope you are excited as well. Tonight I have a very interesting thing. So imagine when an attacker breaks into your system, one of the things that they usually do is they try to get a reverse shell. They want your computer to phone home to their computer using what is known as a reverse shell. So today we're going to talk about how that reverse shell is generated and also how you can detect it. As you can see here, I already have my security onion and it's actually listening for reverse shells and my alerts are firing. So the most important thing here today is I'll show you how to generate a reverse shell, and we'll do it in a fun way. There's a machine from Hack My VM and it's called Family. And it has been 3 weeks since I did a live stream because my family grew. So I figured let's attack a machine called Family, and I have a link in the description here. So thank you all for joining. And with that, let's get started detecting reverse shells in Security Onion. The first thing that we're going to do is, of course, we're going to follow our methodology. We need to start with an nmap scan, then identify what services are running on our machine. Then after that, we're going to figure out how can we detect these things. I understand that attacking is fun, but I will tell you that attacking and detecting, that's a whole different level. I think I have a family folder, nmap. Let's run an nmap quick. -sv, -sc on 192.168.38.223. So we have a victim machine called Family, and it's running on 192.168.38.223. We know nothing about this thing. Our main job right now is let's enumerate this machine. Let's identify the services that are running. Let's find out how we can break in. Then once we break in, let's generate a reverse shell. And once we generate a reverse shell, we'll come back here to see how we can generate an alert just like this one that tells us, hey, reverse shells are happening. In this case, you see there's 20. That's because I have a cron job that was generating them every minute. So the last 20, actually 2 every minute. So that's the last 10 minutes right now. If I refresh this, they should be gone because I just stopped them. Okay, so that's what we're doing here. Let's go and see what services are running on this victim machine. I'm scanning the top 1,000 ports. No UDP scan here, not all 65,000 something ports. I'm only going for the top 1,000 ports. Just a quick scan. In a real pen test or in an exam for some CTF or something, you would like to do a full TCP scan and a UDP scan. But for the purposes of my scans here, you notice that I'm already in business. I see that I have port 80 and I also have port 22, which is a classic CTF move. So WordPress, that's interesting on port 80. We also have Apache with a version here. We can look this one up on ExploitDB, but that will be too easy. Let's go and find out what's running on this WordPress. And then once we find out what's running on the WordPress, hopefully we can have a refresh on how to enumerate WordPress. So coming here, visit the IP address. You see we have a WordPress site. Click on WordPress. It will take us to a WordPress site with French, the language. So what are we going to do here? We know the obvious. We don't even need to use a tool called GoBuster here to bust some directory. We can look for WP admin, because that's the administrator login page. And as attackers, we're interested in this page here because that's where the administrator signs in. So if I do admin, the obvious, which will not work in this case, then we are like, okay, we have a problem. Admin does not work. We know that admin, that's the WordPress default user. And you notice that it's going to family/WordPress.wp admin. So my home DNS is solving this for me. This in the URL here should not be happening on a normal machine. You'd have to add this to your Etsy host. But hey, let's go back and brute force this. First, let's verify that admin is a real user on this system. So we're going to use our WP scan. Let's look for help. It has been a while since we used WP scan, so let's find out if we can run WP scan on this thing. And if you can run WP scan, for the most part, you'll be in business. All right. So we can enumerate some plugins. I leave plugins for later most of the time. I try to start with WP scan just to enumerate some users. So let's actually use -u for enumerate, -e, then for users, because that's the most interesting one. So let's do that. I'll show you the syntax here. Make sure that we save some time. We've attacked WordPress on this site for a long time. I think this is like the 5th, if not 7th WordPress that we have attacked. I used to do this the most when I was going for the OSCP. Rumor had it that they liked WordPress over there, so I went all the way in and attacked WordPress. All right, so right now we're enumerating for some users. If I scroll up, I'm actually going to the WordPress site and I'm saying, hey, do you have any users? Show me some users. I'm hoping to see other users that are not just the admin user. We also are going to the readme.html. Running these two would definitely generate some alerts. I found out that some people would detect when someone visits the readme.html, because most people don't. Then they will identify that that's enumeration, or WP scan gets caught actually. So this is the command that we ran, WP scan, for the URL. This one, going to our site, we had -- enumerate, which is also equivalent to -e for -u. Okay, so found out we have a user admin. Next, let's go ahead and throw roku.txt on that user and see if we can just get a reverse shell. I mean, get a password. This, in most cases, would get blocked if they are using any decent rules, like, you know, if someone is scanning for users, maybe they will time out or they will lock you out. But in this case, I'm just going to say, hey, WP scan, go to my website and use the roku.txt to try to brute force password for the admin user. Let's go back to our security onion and see what this looks like. Sure, we are actually brute forcing right now, and we just started 10 minutes. Let's refresh that. So we brute forced the username. Now we're brute forcing the password. Look at all this. All right, first of all, what we are doing is extremely careless and it's ridiculous, as evidenced by, let's go here. This is the CMS WordPress login attempt. So let's drill down on that alert and see what's happening. By the way, these are default rules in Security Onion. I did not change anything yet. So we're going to this page here. So that's the full log. It's in the Apache Access log. We are already watching that by default, it looks like. And it knows that we're going to WP scan, and it's a login from a Mac, which is what I was trying to use right now. So this was a success. Where was this? It's a 200. Oh, it's just a 200. Okay. Doesn't mean that we succeeded. All right. Let's refresh this one more time. So this is Security Onion intrusion detection system, showing us that we have 160 web server 400 error code. This will wake people up. So if you care about hiding and being stealth, this is not going to save you. 160 of these is definitely going to raise suspicion that something is happening. This is us brute forcing, as you can see here. So if you have been learning ethical hacking and you know how to run some tools, this is very, very important, because now you are getting to see, okay, if I run WP scan, what happens? If I run go bust, what happens? In this case, let's look at this one. This was Nmap. I see right here, Nmap scripting engine. In the Apache access log. So when we're running Nmap scanning the server, that's when we ended up with that. All right, let's go and check to see if we got some results here. Not yet. While we are brute forcing for a password, which is not the most glamorous way of doing things, let's see what else is happening here. If you just joined us, we are enumerating a machine code family from HackMyVM. There's a link in the description for you to download if you want to do so. And we found out that it's running a WordPress website. And right now we are brute forcing for the password for the admin user. And we are looking through Security Onion alerts to see if we are actually logging that. It looks like our brute force is not being logged yet, because I don't see it here. Most of these are going to be from Nmap, so ET scans. All these are Nmap scans. All right, let's go back. All right, so it looks like with the Roku.txt is going to take a long time. I'll let it run here, but to save us some time, let's go ahead and actually sign in, because I already found this earlier. Then I'll show you once it's done. What was the password here? Give me 1 second. I already found this password earlier. That way we don't sit here and wait for too long. BT, it's good to see you, brother. Thank you for joining. And Fahim says, hi, can you also make episodes on Wazuh deployment? Yeah, I'll show. The Wazuh agent is already in Security Onion, so I'm just using that. So our password is this. It's a phantom. Like that. So just this part here. That's what we're going to be using. So let's use that. Perfect. Now let's log in. And we can go back and check on our brute force to make sure that it's still going. Where is it? All right, we're still going. Perfect. We signed in. So the first thing that you do when you get into a WordPress website, without a doubt, is just go ahead and edit the 404 page. Make sure that that page gets your reverse shell. Most of the time, you're going to see that the regular PHP reverse shell is going to work fine here. So we're going to actually use that. So if you go to, I think it's appearance. Themes. There is an edit page somewhere. No, not that one. There's two ways, I mean, more than two. You either mess with the theme or you can go and upload a malicious plugin. In this case, I like to just edit the existing theme. So you go to theme editor. All right. So if you go to theme editor here, you can edit any of these pages and make sure that you get a reverse shell. So the easiest page to edit is the template 404. error, because that's where people get redirected to when they visit a page that doesn't exist. So we can edit the template 404 error, and as you can see here, these are all PHP pages. Going online, you can look up the PHP reverse shell from Pentest Monkey. So let's go ahead. I already have it in the raw format. Just copy this. This is actually from GitHub. Let me show you. By far, the very first PHP reverse shell that I've ever deployed was this one. And it works. You can generate your own using rev shells or things like that. But this is a tried and tested PHP reverse shell that you can use. But that also means that defenders will be looking for this one. So if you are not trying to get caught, you can use this one. If you really care about getting caught, generate your own. But I'm going to borrow this one and copy that. Go to the 404 page. Replace whatever was here in the 404 page with our PHP reverse shell. Then next, you need to modify our PHP reverse shell with your Kali Linux IP address. And please use a different port than 1234. I'm going to use 1234 because I like to search for it in Security Onion. But usually what works is ports like 53, 25, 443, ports that are already allowed by the firewall are the best ones to use here. But in this case, we're just going to rely on this 1234. So if we save this, in this case, that's what this means. Sometimes you cannot save in WordPress like this. Then you know to move away from the theme and go to edit maybe plugins. But in this case, it works. So after that, we need to come back. All right, our brute force is still going. Wait a second, maybe it finished. Yeah, it did finish. This is the password. And the username is admin. So now you know we can brute force for the password. Not the most glamorous way, like I said, but in this case, since it's a CTF, we had to brute force. Once we brute force, let's clear this screen here. Let's use netcat minus LV and P for listen, the boss for numeric 1234. That's the port, the lazy port that I put out there. Now let's see if we can visit the 404 page. I just right-clicked, open in a new tab. It's spinning. Okay, so that's not what I wanted. Let's visit it one more time. It should be, oh no. I think that's it. That's it. Let me remove this. Okay, now let me check it to see if my reverse shell came back. No. Then let's try one more time. We just need to visit that 404 page. I'm going to use the IP address this time to go to the same location, the theme 2021.44.php. Okay, that's much better. And we got a reverse shell. So right away, we know that we're in as www data. Kind of not as exciting, but this is our first initial foothold in the system. Let's verify that we can actually see that traffic here. I'm going to see if we just got a reverse shell, right? So let's see if we detected that one. Well, this video is about detecting reverse shells, so let's check it out. Where's my alert? Okay. Let me drill down on this. I see 18. This is a loud rule. It needs to be modified, by the way. And let's see. 21, 25. Maybe this one. Okay, so this is an alert that is looking for a few things here. I'll show you in a little bit, but this one is looking for bin bash. This is the one that I just set up before this live stream started. And I think that's the one. Let's verify that we could see that traffic from the reverse shell in our Kibana. And we can track down the port that we use, 1234, the lazy port. But as I'm doing that, notice up here that in the last 24 hours, we were happy, and all of a sudden, that's us when we started scanning. So this is a change from the baseline, which also should raise an alarm like, hey, we're getting more traffic than usual. We're getting 4,000 events. Now we peaked at 8,000. What's happening here? That's twice as much. So let's change that from 24 hours to a reasonable amount. Let's change hours to minutes. All right, so from 24 hours, we're now looking for 24 minutes. I'm going to track down that reverse shell that gave us access to WW data on port 1234 using the discover feature in Kibana. Most systems use Kibana as a backend, so if you know the Kibana querying language, then you'll be fine. And this is spinning a little bit, but we'll be there in a second. Maybe we can search for the destination port or source port. Let me do destination port to be 1234. I think that should work. All right, we do get a hit. Got a hit. Is 1234 so generic? This is from Zig. I think I might be in the way. Let me move to the other side. All right. So as you can see here, we just got a reverse shell. If this is true, destination port was 1234. Our connection at temporal was rejected. Wait a second. This didn't work. This is a broken event, and it's telling me that this is a rejected state. We know we got a reverse shell. So what is this talking about? The client IP is the correct. So let's see if we... Let me just look for 1234. All right. I see a few things here. That's interesting. All right, so this looks like different type of traffic. I don't think this is the correct one. Give me this one. That one was rejected. Oh, wait. Yeah, that was security onion. Okay. We'll look further into that one. I'm not sure why I cannot see that reverse shell traversing. I was hoping I can see it correctly, but we can definitely show you the rule that I created to observe the other ones. But this is how you go about digging through Kibana logs to see like, okay, can I see that destination port? Maybe I could have searched for the source port. But before we do that, let's just go ahead and get our flags here. There are two flags, the user flag and the root flag. So right now we are already in as WW data. cd slash home ls minus la. So we have three users, father, baby, and mother. The interesting thing here, as you can see, we're in a www data with these three users. For the baby, we rewrite access and execute. Same as for the father. But for the mother, we have user access, rewrite execute, and mother is part of the father group. That's very important here, because usually a user is part of their own group, but mother is part of the father group, which means that mother might be able to execute things as part of the father group. So let's actually go and interrogate this system further. If you're like starting out and you're like, I have no idea what's happening, most of the time having some notes help. I've been using these notes for like forever. So I want to do some privilege escalation. So in my privilege escalation, I have a cheat sheet. One of the things that I look for, the very first one, is to look for SUIDs. Usually with WW data, it's usually not the way, but why not check to see if we have any SUIDs set on some unusual binaries. Okay. Then let's check for some capabilities. This is my methodology, and I mean SIDs, capabilities. I also check for the ID to see if this user is part of a group. Yes. Right now, as you can see from the output of ID, this user is not part of any other groups. The groups to look for here are going to be your Docker group. If this user belongs to a Docker group, then we're running Docker as a service here. But in this case, we don't even have any. So we're going to move on to capabilities. These are the easy ways of getting capabilities. Ping, I think this one is just normal. That's interesting. All right, I just ran those. Let me make sure that my alerts are still healthy. Then next, what we can do is, the easiest way is, let's run lean peas. I'm thinking, should we do that? Lean peas will show us any files that we can write to, any files that we have permissions to, and any other checks that it runs. It runs a bunch of checks. Lean peas actually would take a long time here. So let's, I don't have environment set. So let's fast forward a little bit. But if you run lean peas here, or Linux privilege escalation checker, depending on which one you like, you'll be able to actually see that we have a file that we have read access to that also says password. You only find that from leanpeas, or you can search for the word password here. But if we go to cd search opt, is it share? Let me find out. There's a file with a password that we can find right here. Give me 1 second. Where is that file? You know what? Let's bring in lean peas. Lean peas will take a while, but that's okay. This is a Linux privilege escalation tool that you can use to check. You should have this on your to-do list. From GitHub, we can do that. Okay, we like that. I'm going to do everything from my temp, because I know I can write there. No, 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 no. I lost my listener. Let's refresh this page. This is how you get your reverse shell back. Okay, I'm just going to show you where this is so that we can reserve our energy for the next phase where we do some lateral movement. So we have to go from www data to another user. We have 3 users. We have the baby, father, and mother here, right? So we need to move between www data and another user before we get to root. So what we're going to do is I'm going to show you where this file is. It's in the user share Perl, actually. If you go in here, in CD 5.28.1, there is a file called perso.txt. If you get perso.txt, there's the words uncrackable password. This is what linpeas catches. So when you run linpeas, the one that I just showed you, it will say, hey, you have access to a file that says something to do with password. And when you open that file, you find the password. So run linpeas is www data, which takes a little bit longer. Then you find this password, uncrackable. So since we have 3 users, we can do some trial and error here. SSH is maybe at 192.168.38.223 and paste that password. Let's see if it works. Since we have 3 users, we get 3 tries, which I think is okay. This is definitely not working. It's definitely not working. And by the way, when that fails, there is a log for it out here. Now let's try the father. So that failed. I will not try again. I'll try as father. I think it's kind of cool that we found a machine that said family. Okay, now let's paste the password. All right, so you can get in as that user, as the father user, when you go and run linpeas and you've identified that there's a file with a static password set in. Okay, once we're in, ls-l, I guess we can do that. We don't have bash history, bash rc. Maybe let's go for sudo -l. Since we have a password here, what can we run as sudo? Nothing. That's unfortunate. Okay, so the mother is part of the father group, as you saw here. So what this means is we should be able to read everything inside of mother. Okay, we got nothing. Okay, so we can bring in linpeas or pspy. Linpeas takes too long, so the easiest one is pspy. Let's go here. I thought I had pspy here. Oh, it's under enumeration for me, I think. There we go. So I'm going to download pspy from GitHub on my victim, make it executable, and run it. PSPy will just enumerate for running processes in real time. And also it will show me if there's any cron jobs that are running. That's a tool that we use. That's actually a good idea. I should have looked for it in my detection, because it's a crazy, interesting tool. Okay, so we downloaded it, made it executable. Now let's run it. This one is faster. It's not as too much work like linpeas. Linpeas will do this, by the way. Okay, it looks like it's done. PS minus EO user PID CMD. Oh, that's why my row is firing. This is running as root. What? Okay. So if I scroll up here, there's a couple of things. A user with user ID of 2, I don't know if you can see my mouse, is running valgrid.bin. This is something I don't know that it exists locally on Linux. That's an interesting binary. I have to check it out. Then let's see. Sudo u. Okay, we can run this as a baby. That's interesting. But we also have a Python script on the home directory for mother. I don't think there is a script. But we are running Python. Oh, wait a second. Maybe this is a cron job. Maybe this is a cron job. But we're running Python here using bash for the check.py that's on the home directory for the mother. So let's go check it out. Maybe we can just become the user mother. ls-la. It's not there, actually. Here's my pspy.py that I was able to write here as father. But we do not have that file that they're talking about. And it was called checker.py. Forget it. Let's create that checker.py. But we're going to create it in a fun way. We're going to use revshells.com. I'll put my Kali Linux IP address, port 555. That's fine. I'll use Netcat as my listener here. This is Linux. I like a reverse shell. For Python, I just want Python 2. You'll notice that if we go back, let's run it again. This is where, if you're just a script kid who knows how to get reverse shells, but it doesn't know what's going on, you'll be in for a little treat here. Because look what's happening. They're already running bin sh -c Python. If you look in my reverse shell, it's also running Python -c. That means that in my file, I do not need this part. I'm going to need only the import part. But instead of spawning, I need to call for that process. So I need to lose this part as well. So we need to modify this. All right. So let's modify it for a second here. So the one thing that we know for sure we do not need is the Python -c at the beginning. I guess I could have used Obsidian or something, or my notes. Yeah, let's share with PSPy here for a second. All right, where's my ref shell? All right, just a moment here. Let's make sure that, oh, this one is still moving. We don't need this anymore. Let's close it. And so is this one. We don't need it anymore. We're already in now. So all that's left for us, we also don't need this one. This is where I'm running the machine. It's running in VirtualBox. I didn't show you that in the beginning. I'm just going to use the browser for modification purposes. All right. We don't need this part here, the import -c. It's already being done by PSPy. We have the import spawn here. This will not bring us a shell if we use it. So I have a modified version of that. That's going to be subprocess.call. So we need to get rid of this. And let's make this into an interactive shell. Comma, I don't need a space, -i. Then let's close that. Okay, so now this should work. All this slight modification, mostly because if you look in the results of PSPy, we're already calling Python. So if you call Python a couple of times, it won't work. I did spend a couple minutes looking through that, so I'm saving you some time. It's already using Python -c to call for checker.py in the home directory for the user mother. So let's do this. Let's echo that. Looks good. We're putting it in the home directory for mother, which is where it's running from. And that looks good. Let me just do a double check here. Subprocess.call. I think that's what I had here. P is goes to subprocess.call. That should work. Like this. I'll leave it to port 555. Maybe my favorite port, 5353. I think it's symmetrical. I'll do 5454 so that we can actually see in real time the new port that I just made up right now. So at the end of this, we should be able to track down the reverse shell to that port. All right, that looks good. So this will make our bash shell interactive. So let's start our listener. I think there's a cron job that's running every minute or so, because if we wait for it for like a minute, this listener here should give us a reverse shell. But I bet there's nothing in the further cron. Can I even see that? Yep, I should be able to. All right. No, this is just the main one. Yes, pin. All right. Let's hope we get lucky and we get a reverse shell here in 60 seconds. And while that is happening, we'll go back and try to see what we can find on our system. So destination.port of 5454. That's the one we just created. Let's search for it. Okay, maybe it hasn't ran yet. Once it runs, we should be able to see that. Destination.port. I think That's what it should look like. Let's look at our main alerts. And find out what's happening. Okay, I already have a rule that's firing here that says reverse shell listening for incoming connections, which if I drill down on that, I'll show you why it's firing. This is why I wanted to show you tonight. But just as a quick recap, this one here will fire every time we see, as you can see, it's so bin bash minus I from the user mother, which is what I just had in my reverse shell. And let's see if it actually came back. Cat. Was it called checker.py or something else? Let me. Oh, I'm silly. I named it checker.py. It's actually named check.py. Of course, it's not going to fire with checker.py when it's named check.py. Let's verify that. Somebody should have said something. Yeah, it's called check.py. So now that it's called check.py, we should be able to see a reverse shell coming back here in a second. "60 seconds," I think that's what it says. Okay, and it looks like somebody is spamming us, so let's ban them. Yeah. So now that we have a real reverse shell there, let's check it out. What does that look like here? Yo, did you find 5454? Not yet. It's now a waiting game to see which one is going to show us. To see if our reverse shell is actually going to come right on time. It's 60 seconds, I think, from the cron job, if not 120. Let me close this one. Let's go back to this one. It's clear. Just to make sure that I didn't make any mistakes in my reverse shell, I'm going to echo it one more time. And show you and go through it together. So we're going to echo the import socket subprocess reverse shell. That one is going to be 555. I want 5454. Okay. Oh, it didn't work because I didn't have a semicolon at the end. There we go. So this is our check.py. Come on, give me a reverse shell. And when it comes back, this search here that is giving us nothing, we should be able to search for it here, and we'll be able to see some results once they're indexed. And then, of course, our alert will fire here. That shows us that we did indeed get a reverse shell from there. So still waiting. And I think this one works. Let me check using PSPy. What else actually I can find using the reverse shell? I'm still stuck on this val grid bin that's being ran as this baby. It's actually being ran as by root, which is interesting. But then we have this user ID of 1001, which I think that's the mother user. Yeah, because of this. I do not know where that is happening. Let's check. All right. I was buying time because the cron job had to run at some point, and we are in as mother. So if what I said was true, my destination.port of 5454 should now give me results. Don't mess with me. I should see something from 5454. All right. While it's indexing, let's escalate our privileges here. Okay, sudo -l. Okay, this is the val grid binary that we saw last time from PSPy that we ran. And we saw that it was being ran as this. This was a result from PSPy. So I'm just running it the way it was. What? So we're in as the baby now. So that was a way of switching from mother to the baby. That was the biggest switch. So we went from the father to mother. Now we're in as baby. Okay, I'll take that. Let's stabilize this. Well, not really stabilizing. We're just making it so that I can clear my screen because I like to type this clear command here. ls sudo -l. I'm in as the baby. I know that. Oh, okay. This is useless. Or user bin cat. So I can use the cat command without a password. Well, as a baby, I can run the cat command. The obvious thing that I can cat for is such root in the .ssh id _rsa. That's the one thing that I think of. The root such .ssh id _rsa. So if there are any keys there, in this case there is, the root user's SSH key. So we copy that. Make sure that we copied a clean copy. So we now have the root user's SSH key here. I guess this is let me go to my temp folder. Okay. Let's put our SSH key in here. Come on. So let's give it SSH mode 600 because that's the permissions we need. SSH -i for ID _rsa root at our IP address. All right, yeah, I would like to get in. What happened? I messed up. Do I need how many do I need? 5. 1, 2, 5, like that. There we go. So here's the thing. This kind of throws us a little bit. If we hit enter, you notice that the connection closes. This frustrated me earlier. So if you put an exclamation mark / bin bash, you escape that. Now you're in. Cat last flag text. So here's our last flag.sh. So we successfully rooted the machine, but we are not done yet. Let's go track down our reverse shell first. Well, first of all, we have port 5454 that we got a reverse shell on. Then I'll show you a root password that we have. Okay, so this is port 5454. Perfect. We can see it this time. Let's move me out of the way. So what happened with port 5454? Well, we know that we got a reverse shell. So here's a rejected attempt, probably the first time. Let me pick on the one down here. Okay, this is a good one. So Zeke did see established, but aborted. It's probably the one that we got. But this is the one of the reverse shells from Zeke, which is a tool that you can find from, I think it's Corelight. This one was rejected. All right. How do we monitor Linux reverse shells, which is what the title of this video looks like? So I'm monitoring this system, right? So I installed an endpoint monitoring tool called Wazuh Agent. This comes pre-configured with Security Onion, and as you can see, mine is already running. In Wazuh Agent, we need to tell it, hey, we would like you to listen for a few things. So there's 2 settings that we need in order for us to monitor a Linux endpoint for processes that call for a reverse shell. We can go for like, hey, netcat gets called, or we can monitor a process like, bin bash. So in this case, let me see if I can. I don't have much in here. Let me show you where the rule is. So if you use in the var osec etc osec.conf, that's where we keep the monitoring agent. So if you have a computer that is running, there's a piece of software called Wazuh Agent. This is its configuration file. In this configuration file, you can tell it what to watch for. In this case, I told it, hey, I would like you to connect to my Security Onion. So this is my Security Onion IP address on this port 1514. It knows to connect there and send all these logs. By default, it has all these things here that it's doing. The one that's actually getting me the data that you are looking at, that's generating all the alerts, which I'll show you in a second here, is this one down here. I'm almost there. I just want to show you the whole thing. This is where we are looking for the Apache access logs. When you saw it complaining about Apache and things, it's looking at it from here. So this agent is also looking for the var log in the location, but it's running this command, ps-eo user pid cmd. It's listing things that are running on the system. So let me copy that and run it and show you. So the agent is running this command on a regular basis. It's listing who is running the process and what the full command looks like. So as you can see here, it can tell what ran. So when we run our reverse shell, it will show up as one of these, including this bash -I. So all we're doing on the agent is we're running this command, the PS command, listing the user, the process ID, and the command that they ran. Then we're shipping all this noise, which is a lot, by the way, to our security onion intrusion detection system. So what does security onion do? Let's go to security onion. This is my security onion. In here, I have in the OPT, so I have some local rules. I'm getting all that output of all the processes that are running. But then all the way at the end, I tagged in a rule, which I found somewhere online. There's a bunch of rules here, but this is where the money is at. So forget this CTF stuff. Forget getting a flag. This is exciting stuff. So we're saying, hey, we're creating a rule and we're looking through the OSEC stuff. We give it a rule ID, which is just some number. Then SID of 530. We're saying, if output of this command here match, in this case, this is just listing all the processes, then let's have a rule. If we see bash, let me know. If you see perl, let me know. Because this is what most people put for their reverse shells. If you look in the Pentest Monkey reverse shell list, they darn it. Let me show you. Let's go to the Pentest Monkey reverse shell list. I'm just using a different screen. So if we go here on the main Pentest Monkey site, not that one. Anyway, most of the reverse shells are either Ruby, and they all start with this. If you look them up, they all start with this. Or SSH -I. That's also another indicator that someone is trying to use a different key. Or if you see someone fixing Xterm, Xnet, Xhost, or Netcat, the one that will get us busted today is this Python -C. Remember my command earlier that I was struggling with trying to fix, the Python -C? That's the one that got us busted, this one. This one started with Python -C, then import socket, and so forth. That one got us busted. So that will generate a reverse shell for us as well. So this is the rule in the Wazuh agent that is generating these alerts. Let me show you what they look like. So you see I have 20 here. So what happened here is I left a rule that was generating my reverse shell as part of a cron job. And every time the cron job ran, my rule got triggered. So if I drill down here, the same rule that I was just showing you, it says reverse shell listening for incoming connections. It says low. I need to bump this number here. I need to make this one into a high severity rule. But you notice that the agent name was family, because that's what I named it. And here is the command. And bin bash -I is what got us caught. But I think there should be another one with Python -C. There has to be one with Python -C somewhere. So this one says bin bash -I. Oh wait, all of them would say bin bash -I because they all start with bin bash -I. But that's how you can monitor a Linux host and be able to actually get it working. If you have any questions, let me know in the comments or reach out to me. But this is a very simple way of setting up your Linux host to be able to understand what processes are running and also which ones are trying to have behavior that is reverse shell like capabilities. If you like this, please make sure to give me a thumbs up. This is very interesting stuff. It's not your typical CTF, hey, let's get a flag and go and sing Kumbaya. This is more like, hey, let's get a flag and have fun. But also, let's look through this traffic. Let's understand what's happening with it. And also, let's get it in a way that we can detect, and how is that detection working. If you can do this and if you can master this, I think we're going to go somewhere here. And that's so far what I had. Oh, I have someone as well who's trying to spam my chat. Okay, that was fun. All right, everyone. Thank you for being here. That was fun. I hope you learned something today. If you have any questions, like I said, let me know in the comments. Otherwise, I hope to see you next week. I set up an Exchange server that we can attack and actually detect the latest 0-day. I'm still not sure if it was patched or not. It's not clear. That's why I didn't live stream it tonight. But next week, we're going to be looking through the Exchange vulnerability and how to detect it, and also set up some rules for it. So that's going to be fun. Don't miss next week at 9 p.m. Central Standard Time. Otherwise, give me a thumbs up, like and share, and comment in the below. Otherwise, see you next week.